So yesterday, we learned that you could read chemical equations in terms of moles. And that's going to let us figure out how, because we'll be able to do mole-to-mole conversions using that balanced equation. So, and what we're going to use is the coefficient. Okay, so those coefficients are how many moles interact, so we can use those moles as conversion factors. So for example, in this balanced equation, it says I can read this as 2 moles of Al2O3, make 4 moles of Al, and 3 moles of O2. Okay, so that allowed me to answer questions. And what I use are the coefficients. This equation up here says every time I use 2 moles of Al2O3, I will make 3 moles of O2. So I can use those coefficients as my conversion factors. So we can go from moles to moles using the coefficients. That's the new piece we're learning today. So if you push those buttons, 3.34 times 3 divided by 2, it works out to be 5.01 moles of O2. And that's all there is to it. You read the coefficients as moles because we can read the equation in moles. So let's work out a few examples, and then you can start the homework. Okay, so this is the balanced equation for what happens when you use an acetylene torch. This is acetylene. Okay? And if you ever notice when they use torches, they always have 2 tanks, one full of acetylene, one full of oxygen. So you'd have to measure how much oxygen and acetylene you had. And one of those ways is one of the ways to measure that is in moles. So if I was buying these tanks, I'd need to know if I had enough oxygen. So if 3.84 moles of C2H2 are burned, how many moles of O2 are formed? So I start by writing down what they gave me. 3.84 moles of C2H2. Set up my conversion factor to get rid of moles of C2H2, so it has to go on the bottom. And I can turn moles of C2H2 into moles of anything else in the equation, and since they asked about O2, I'm going to choose O2. And the coefficient in front of O2 is a 5, and the coefficient in front of C2H2 is a 2. Oops. So those are my coefficients. I've built my conversion factor. So now all I have to do is push buttons. So 3.84 times 5 divided by 2 is 9.6 moles of O2. Pretty straightforward. Just take the numbers out of the equation. Here's another example. Same equation. If I found out that I had made 8.95 moles of H2O, how many moles of C2H2 did I burn to produce that? So it doesn't matter whether it's a reactant or a product. You write down what they gave you, and you can turn any reactant in the equation to any product and vice versa. So it doesn't matter where it's at. Okay? I can change anything in that equation into anything else. So 8.95 moles of H2O. So I put moles of H2O on the bottom and turn moles of H2O into moles of what they asked for. And since they asked for C2H2, the number in front of C2H2 is a 2. In front of H2O is a 2. And there's my conversion factors. 8.95 times 2 divided by 2. I don't need a calculator for that one. It's going to work out to be 8.95 moles of H2O. Or sorry, moles of C2H2. I got rid of moles of H2O. So notice the reason why I write the chemical is because I can change the chemical. This conversion factor didn't change the number. All it changed is what chemical you talk about. So we change chemicals using mole conversions. And I can turn it into, I can react with anything in it. So this time I want to know how much CO2 I'm making. So if 2.47 moles of C2H2 are burned, I want to get rid of moles of C2H2 and change that into moles of what they asked for, CO2. The number in front of C2H2 is 2. The number in front of CO2 is a 4. I push those buttons in my calculator because the moles of C2H2 have canceled out. I'm left with moles of CO2, which is what they asked for. And 2.47 times 4 divided by 2 is 4.94 moles of CO2. So we can go directly from moles to moles. So if you use this equation a lot, it really doesn't matter what the equation is. Here's an old familiar one. So I just have to make sure that I keep track of what they gave me. They gave me 5 moles of oxygen, and they asked about moles of H2O. And if I want to change chemicals, I can only do it if I have a balanced equation. And I have one. So I can start off by writing the 5 moles of O2, because oxygen's O2. Get rid of moles of O2, the unit they gave me, and turn it into moles of H2O, what they asked for. The number in front of H2O is a 2. The number in front of O2 is a 1. So 5 times 2 divided by 1 is 10 moles of water. Pretty straightforward. Your homework will have you practice some of these, and we'll use this to move on tomorrow. Have a great afternoon. Talk to you tomorrow.